The Boeing 747-8 and Airbus A380 are titans of the sky, clashing with each other for dominance of the airways. These twin-level aircraft move packs of people across the world at a pace which was once unimaginable. They offer airlines a mix of technical sophistication, luxury, and the promise that they will become the golden geese of their fleets, something for which airlines are willing to pay hundreds of millions of dollars. The lineage of these advanced aircraft can be traced back to the pioneer days of commercial aviation, when moving a handful of passengers was an achievement. Many giants would come before the 747 and A380, and many would fall. As bold as these aircraft may seem, new breeds are on the rise to surprise and surpass them all. The Boeing 747 jumbo airliner, an icon among all other commercial aircraft of the time, and an absolute cash cow for those who invested in it. Equal to the jumbo's size was its massive cost, far more than its designers could afford. Boeing had to look for partners, and big ones. But despite its success with the earlier 707 jet airliner, the money needed would be hard to find. Boeing thought that a likely candidate might be General Motors, one of the largest companies in the world at that time. They were to be disappointed. The car maker did not want to put its profits into an entirely different industry, and so it was that Boeing looked closer to home. In the end, two other aeroplane makers, Northrop and LTV, formed a triad to share the costs with Boeing and, ultimately, to enjoy the very considerable profits. The 747 actually had its origins in a design competition for an even larger type of military transport, the C-5 of the U.S. Air Force. Eventually, Lockheed won that contract, although not before Boeing had concluded that aircraft of such large size would be more useful when the flight deck was raised above the main floor, which permitted greater area for payloads of every kind. Boeing retained the two-level idea, and it was used in its next project, the 747.
Boeing used a lot of the design for the C-5 and put it into what became the 747, particularly in the wing and the engine technologies that were used. Probably without the C-5, the 747 would not have happened. Certainly, it wouldn't have happened as quickly as it did.
Both the 747 and CX-5 would require a new breed of engine to get their supersized airframes off the ground.
To make a big jet work, you've got to have a big engine. And the 747, of course, required 4 of them. And technology had developed, had advanced during the 1960s to the point where you could come up with the very first high-power, high-bypass ratio engines. And what that means is not all the air goes through the core. The core of the engine is where the compressor and then the combustion chamber and then the turbine are. But these engines had a big shaft goes out the front and turned a great big fan to blow air around the hole outside of the core of the jet. So a high bypass ratio engine. And those are quieter and more fuel efficient. It was part of the whole gamble that Boeing took to produce the 47 because, big airplane, big engines all being tested and produced at the same time.
The aircraft was envisioned originally with 2 full-length decks, much like the A380. Oddly enough, Boeing did not see the iconic 747 having a lengthy career as a passenger plane. Supersonic jetliners were predicted to be the way of the future, and if Boeing's hunch was correct, the 747 would soon be relegated to cargo craft duty. Cutting the aircraft in half with a second deck would limit the kind of cargo it could carry and its utility in this role. As well, a 2-level passenger plane might present safety concerns. How would passengers on level 2 get out in an emergency? The costs of producing such a bold flying machine would be astronomical. Given these complications, the second level was shortened to form the 747's trademark hump. The cockpit placement was certainly influenced by the 747's anticipated cargo duties. It resides behind the nose and at the very front of the second level. This allows the nose to serve double duty as a swinging doorway into the cavernous cargo area. It was unclear what to do with the space behind the cockpit, particularly with the passenger version of the 747. Early on, the 747's upper annex was designated as crew quarters, although in the event it was employed as a passenger lounge. To Pan Am's president, Juan Trippe, this was a waste of space. So extra windows were added, and this valuable real estate was quickly converted for seated, paying passengers.
The early 747s had a small bar and entertainment area for first-class passengers on the second floor just behind the cockpit. And they were not certified for occupancy during takeoff or landing, so they were only usable as bar areas. But they overcame that restriction with some second deck escape chutes. And of course, most of the 747s were later built with seats up there.
I was a child then when the 747 first came into commercial service in 1970. And what I remember was the passenger appeal. They had really studied things from the passenger's point of view to make it a more pleasant experience to fly somewhere.
With the upper deck devoted to seating, now the term double-decker seemed very appropriate. Advertising agencies felt they had a novel feature to sell to the public, so much so that airlines with early jumbos actually had extra mock windows painted on their 747s as a piece of commercial set dressing. The double-decker layout was far from new. Even before World War II, Short Brothers had developed the twin-level British Empire flying boat.
The Empire flying boats were built to serve the Empire, obviously, and did quite a job between the wars in the 30s, flying the kangaroo routes from London to Australia. And of course, they had the most magnificent stops along the way, and carrying 25 passengers and 2 or 3 stewardesses through places like Baghdad and Calcutta.
The deep draft of the hull provided extra interior space for a second deck. The top floor was divided into 3 main sections: the cockpit, the clerk's office, and a mailroom. A little-known fact is that these flying boats were derived from the manufacturer's basic design for a 4-engine bomber. Passengers resided in a luxurious lower level, which included a smoking cabin, the galley for pampering travelers' gastronomic needs, restrooms, and 3 cabin areas.
It was a level of luxury in flying that we haven't seen since, I think.
At the very rear was a second mail or cargo area. It was a luxurious and expensive flying experience. Passengers might pay the equivalent of a year's wages for a ride across the Empire. Actually, as far as the British were concerned, their most important payload wasn't the passengers. Rather, it was the mail. Using this new medium, Short Brothers double-decker flying boats were able to bring together a commonwealth spread around the world like never before. Now, businessmen, bureaucrats, and families, all living overseas, would benefit from what would then seem like a much smaller world.
Boeing's double-decker Model 314 was a newer vintage than the Empire flying boats, although they were bigger, much bigger. 314s in Pan Am service were known as Clippers.
It had sponsons instead of wingtip floats, which was thought to be original. It was original and thought to look much better. And it went into service for Pan Am Airways from San Francisco to Hawaii and out into the Pacific Islands to Australia eventually.
When suitably configured, they could carry up to 77 passengers, more than 4 times that of its British counterpart. Also, there were plenty of catering staff, including chefs poached from the top 4-star hotels. The 314 was a true exercise in giantism. It was the offspring of a previous Boeing behemoth, the XB-15 experimental long-range bomber, an aircraft massive in every regard and from which the 314 inherited its wings, as well as many valuable lessons in the making of very large aeroplanes, knowledge still being applied 3/4 of a century later.
Both of the early double-decker flying boats were to become thoroughly absorbed in the horror of the Second World War that was to follow. The great size of Pan Am's various clippers also translated into much more range, sufficient in fact to cross the Atlantic. However, as impressive as that capability seemed in peacetime, under one wartime scenario it would be insignificant. Getting from the U.S. across the Atlantic was one thing. However, if England fell, like most other European countries would, then the only way the U.S. would wage war with Germany would be with bombers that could fly the Atlantic on a there-and-back return trip basis. An aircraft with such range would make even the massive XB-15 seem small. In 1939, it was hard to contemplate an aeroplane of such size. The imperatives of war insisted that it could, and so it was. By 1946, when the war was well and truly over, the first B-36 rolled out of Convair's hangar in Fort Worth. By any standards, this was one big airplane, and able to carry sufficient fuel to fly nearly halfway around the world. As big as the B-36 was, it was morphed into an even larger double-decker transport, the XC-99. Though it shared the wing, tail, and other features of the B-36, and it lacked the jet boost of the intercontinental bomber, what really made it stand out was its towering fuselage. It seemed as if Convair had stacked two of them together to create this ungainly-looking flying machine. Though not the prettiest aircraft, it had passenger capacity. 400 troops could be ferried at once. It's likely the temptation to go for a military transport version was influenced by the fact that so many of its parts were common with the B-36s. Maybe equally important was the prospect of a civilian order from a major airline. Convair hoped to use this same basic design as a passenger plane, the Model 37. Several U.S. airlines expressed genuine interest in a double-decker aircraft capable of accommodating well over 200 passengers in luxury. The interior decor would have been the artistic challenge of a lifetime for any self-respecting designer. However, it was never to be. No commercial orders were ever received. The airlines were weary of the high fuel and other operating costs for such a giant airliner. Overheads that would have meant nothing to the military were totally critical to the likes of Pan Am and American. Also, as attractive as its passenger capacity was, would the airlines have been able to fill those 400 seats to make operating the XC-99 economical? And could airports cope with those passengers? One byproduct of the war was the construction of hundreds of airfields. However, most airports were in a fledgling state and were not equipped to process that many passengers at once, at least for the time being. As a troop transport, the XC-99 didn't do much better to improve Convair's bottom line. It was a one-off. Other, smaller, more practical transports were soon available, including Douglas's twin-level C-124 Globemaster II. Still, the one and only XC-99 did soldier on, providing valuable service to the Air Force. The XC-99 was not the only double-decker giant of that time. Even before the B-36 was morphed into the XC-99 for the Air Force, the U.S. Navy was looking to find an extra-large people mover as early as 1942, just as the U.S. was actually entering World War II. Despite the war, the Navy joined forces with Pan Am, which had originally conceived the Constitution Project, a massive civilian airliner. Even then, the airline was looking towards a post-war passenger boom. The unique military-civilian combination came together to produce one of the boldest experiments in air transport history, although it was the military that paid the bills, and there would be plenty of them due to the enormous problems of size involved. The big answer to the Constitution's design came from a competition between two other rival aircraft companies. Only a few years earlier, Curtiss Aircraft was committed to making a truly advanced 2- or even 4-engine airliner, one that would be far ahead of the famous Douglas DC-3. Curtiss model CW-20 was to have passenger accommodation that was pressurized, allowing travelers to be flown at altitudes not practical in the past. Could this be done? Boeing did have a similar concept, the Stratoliner. This was a pressurized airliner, largely formed from the parts of the Boeing B-17 bomber, so it was possible. Curtiss designer George A. Page Jr. thought he could do much better than Boeing, and so he and his team started to develop something quite revolutionary for that time. The aim was to have a cylindrical cabin to cope with the pressurization, without the usual wasted area typical with that layout. In the Stratoliner, much volume was lost by adding a floor. The Curtiss team took a step back and cleverly looked at ways of modifying the cross-section of the fuselage. They found if they creased the fuselage at the sides and laid a floor along that line, they could create a shape that was safe, very strong, and conserved space. This oblong fuselage was incorporated into their CW-20 design. The top level was pressurized for passengers, and the lower one was for cargo. Some referred to the structure as a figure of 8, although it soon became known as the double bubble.
The double bubble fuselage was used because it's more efficient structurally. It's lighter structure and provides extra room in the belly for cargo and a nice wide cabin for the passengers. Became very popular, still used today in numerous transport aircraft designs.
The C-46 ended up as a mass-produced military transport with 2 engines and no pressurization at all. Bigger than the C-47 Dakota, but perhaps not quite as loved. Willis Hawkins, Lockheed's chief designer, quickly saw the double bubble's potential for developing the giant Constitution project. Rear Admiral Faitner recalls the spacious interior of this new aircraft.
R6O, which is the biggest airplane we ever owned. You know, these were the airplanes that had spiral staircases, fore and aft, double-decked. So this is a huge airplane.
The twin-hull concept provided a double-decker layout well-suited for pressurization on both decks. With this critical design element resolved, planning and even production could proceed. However, these tasks were awesome by any standard. To begin with, a 4-acre, 6-story-high hangar had to be built in order to accommodate the 150-foot-long double-decker fuselage and 190-foot wings. Due to the priorities of the war effort, as well as the Constitution's challenging proportions, the first of this type didn't actually fly until the 9th of November, 1946. It was apparent that the aircraft was underpowered, especially on takeoff and with full load. One quick fix that was becoming fashionable at that time was to use rocket-assisted takeoff, at least until more powerful engines could be fitted. However, the first rocket-boosted takeoff nearly ended in disaster.
So I got out there and started down the runway, lifted the nose wheel off. Just before liftoff, I said, "Fire the rockets." And I pulled back on the yoke, got airborne, and nothing happened. Not a JATO bottle fired. Now we're on what we call the backside of the power curve. Your drag is higher than your acceleration, and you're in irons. You're just going along. And something we hadn't figured on, the drill hall at Pax River was dead ahead of us, and we were below the top. And there's no place you can go. So sitting there waiting on the crash to come, the top of the drill hall is a hemisphere. there's a thing called ground effect. When you get one wing, a half a wing spread from the ground or a solid object, you get extra lift, a cushion of air. Came up to the drill hole, and the formation was just right. It lifted us over the thing, down the far side, got up there on the right side of the power curve and accelerated. It took us over 25 miles. We actually got over the river, which is about 25 miles west. We got over there, and the sun was on the water, and we finally were able to get control of the airplane again. But that was a long 3 minutes.
The passenger-to-trip ratio must have seemed tempting to airlines at one point. However, despite the fact that it was purpose-built and the first to be developed, the Constitution fared little better than Convair's XC-99. Neither Pan Am nor any other airline showed the expected post-war interest in extra-large passenger planes. Perhaps in some ways, both aircraft were ahead of their time. Both were underpowered for their size. However, in several years, more powerful jet-prop engines would become available. These would have improved the power-to-weight ratio of these behemoth airframes. As both of these remarkable experimental aircraft slipped away, the Constitution, at least, left one major legacy behind: the double bubble. Immediately after the war, a fairly efficient double-bubble airliner did emerge. This came in the form of the Boeing Stratocruiser. Just as their Stratoliner had been assembled largely from B-17 parts, the Stratocruiser similarly borrowed from the C-97 Stratofreighter, which had, in turn, borrowed from the B-29 Superfortress.
The Stratocruiser was a passenger aircraft built for Pan Am and BOAC, which basically used the wing from the B-29 with a new double-bubble fuselage.
Boeing President Bill Allen was attempting to get the most value out of technology developed during the war while shifting into peacetime civilian aircraft production. It was a bold move. He moved forward with his plan before securing a single customer. However, the gamble paid off in extraordinary fashion. The first order from Pan Am for 20 Stratocruisers was the largest in commercial aircraft history, the equivalent of over $300 million today. Pan Am's president, Juan Trippe, had high regards for Boeing, given his experiences with the Clipper. He was also aware of the fact the earlier Stratofreighter could fly from New York to Seattle in a little over 6 hours. He could use that as a yardstick for what the Stratocruiser could do for his airline. Boeing's double-decker had a decent amount of seating for the time. Above was the main passenger area, which could accommodate up to 100, while below was a lounge for 14 people.
Featuring in the belly of the aircraft a full bar, stand-up bar for first class, or Monarch class, I think as BOAC called it. They were the days, and they were very, very popular aircraft.
It was a comfortable ride. In addition to having a pressurized cabin, it had a new feature most passengers now take for granted: air conditioning. In the first 6 years, the Stratocruisers would ferry over 3 million passengers and cross the Atlantic almost 28,000 times. The aircraft, however, were far from perfect. They were expensive to buy and operate. There were also several serious accidents, including the crash of Pan Am Flight 202 on April 22, 1952. The propeller and engine separated from the aircraft, and it crashed into the Brazilian jungle. All 50 aboard were killed. Ultimately, only 56 Stratocruisers were produced, including the prototype. The same double-bubble technology of the Stratocruiser would also produce the largest all-metal flying boat ever made, the Saunders-Roe SR-45 Princess. At war's end, BOAC, the British flag carrier, was looking for a long-range transatlantic flying boat. Saunders-Roe put in a bid and won a contract to produce 3 aircraft. The project was, in some ways, doomed from the get-go. Though aircraft like the Empire flying boat and Clipper had been successful before the war, times had changed. The same war that had devastated Europe and many other parts of the world had also produced a network of runways and airports. Flying boats had bound together the sprawling British Empire, but by the late 1940s, they were quickly becoming obsolete. Though named the Princess, she was anything but elegant, more of a leviathan. She was 150 feet long with a 200-foot wingspan, more than that of a 747. It took 6 propellers, powered by a total of 10 Bristol Proteus turboprop engines to get her into the air. The additional engines were needed to help spin the 4 inner pairs of contra-rotating propellers. In terms of seating capacity, she was on par with the Stratocruiser. The first of the aircraft made 47 test flights between 1952 and 1954, but she was the only one that ever left the ground.
The unreliability of water operations and the penalty of the extra weight it incurred in the fuselage to withstand the forces of landing on water made it totally uneconomic. The Princess died a quiet death, unfortunately, but it was totally unsatisfactory from an economic standpoint.
Jet-powered transports were starting to come online. These speedy, streamlined aircraft, combined with the freshly paved runways, made the costly and complex Sea Giant redundant. As well, with a land-based jet plane, there was no worry of seawater corroding the aircraft. It was, in fact, corrosion that finally did in the 3 seaplanes. In the mid-60s, an offer was made to purchase the aircraft and use them as freighters to ferry rocket components for NASA. However, they had rusted away in storage and had to be scrapped. It was an undignified end for a princess. Now, there was a much smaller double-decker aircraft flying in the 50s. It wasn't quite as small as a jelly bean, but looking at its distinctive profile, it's not hard to understand how it got its nickname. Also known as the Dupont, or the Breguet 761, or 3 or 5, this double-decker aircraft was conceived during World War II. Its 2 floors were linked by an elevator in some models, and it could accommodate up to 135 passengers. The Dupont aircraft was not pressurized and was intended for medium-range routes. It first flew in February of 1949. The French government purchased 6 for Air France and 6 for the Ministry of Transport. Air France mainly deployed it on European routes from Paris to the Mediterranean. In all, only 20 were built. Like the Princess, it was done in by the jets. By the mid-50s, jet aircraft like the Sud Aviation Caravelle were available, which offered a more comfortable ride and greater range. The French Air Force had ordered the Sahara freighter version and eagerly snapped up Air France's jelly beans as they were phased out. Instead of ferrying passengers, the French Air Force used them in a toxic role, moving personnel and materials to nuclear test sites in the Pacific. The double-decker concept was abandoned for a time. However, the double bubble still popped up in plane designs from time to time as an ingenious solution. British aircraft manufacturer Vickers Armstrong had made a highly successful aircraft called the Viscount, a short to medium-range turboprop airliner. They followed with the roomier Vanguard, an aircraft which quite literally built upon the success of the Viscount's design. The Viscount's fuselage was cut in half, and a new, larger fuselage was layered on top. Vickers Armstrong were not interested in creating a second passenger deck with this procedure, as had been the case with the Boeing Stratocruiser. Instead, they used the double bubble to create more cargo area beneath the floor and a more spacious cabin. Sandwiching the layers together was not without penalty, however. It was heavier and needed more powerful engines. Rolls-Royce more than delivered to address this issue. Married with Rolls-Royce Tyne engines, it became one of the fastest turboprops ever created.
It was known in Air Canada as the mudguard, by the way, and it was highly regarded by the pilots, but its level of vibration in the cabin was a serious detriment to comfort. The Tyne engine was a troublesome engine at the best of times.
These same Rolls-Royce Tyne engines might have powered a beefier British-made double-decker. In the 1960s, the RAF were looking for a new freighter, one with a massive carrying capacity, large enough to hold helicopters or even 200 troops. Short Brothers responded with the hefty Belfast design. Its interior was cavernous by the standards of the day. The Belfast's 18-foot diameter fuselage could hold 2 buses side by side and had a maximum takeoff weight of 100 tons, more than that of a Lockheed C-130 Hercules. Unlike some of the earlier giants, this was not a double-bubble aircraft. Rather, it had a large diameter circular section pressurized fuselage. The RAF ordered 10 of these hulks. As promised, they could accommodate helicopters, up to 2 Westland Wessexes, or 6 Westland Scouts, although they didn't reach the target for troop capacity. It could carry 150 only. Short Brothers tried to capitalize on the basic design by morphing it into a passenger plane. They pitched the idea of a double-decker with close to 300 seats to BEA, but the proposal went nowhere. This was not the only British-made double-decker airline proposal of the 1960s. Vickers dreamed of taking the lead in the jetliner market with their own superb design. In the mid-60s, the Vickers VC-10 was struggling for its life against the likes of the 707 and DC-8. Even BOAC had turned up its nose at the homegrown aircraft. The VC-10 had the advantage of being able to land on short runways, common in some of the less developed regions of the British Empire, but the 707 had quickly swallowed up the market, and larger runways were multiplied to accommodate it. Vickers proposed repeating the operation performed on their Viscount years earlier. What if they sawed off the top of the VC-10 and fused it with another to create a double-bubble fuselage, one large enough to have 2 full levels of passenger seating? It would have been economical to build, and it could have held almost 300 passengers. Unfortunately for Vickers, the same year their proposal went out, Boeing announced it would be building its own double-decker, the 747. The 747 was part of a new democratized era of travel. It was no longer a luxury exclusively for the rich and famous.
In the 60s, if you went on a flight somewhere of any length at all, it was either you were well off or there was some sort of business reason to do so. And people dressed up in, shirts and ties and all that sort of thing. Girls had little dresses on. But by the end of the 70s, the prices had come down since there were so many seats available, and flying was becoming part of the everyman's choice in life.
The success of Boeing's Jumbo hinged not only on airlines buying the airframes and passengers purchasing tickets, but also that the infrastructure was in place to accommodate their jumbo-sized needs.
As passenger aircraft evolved, particularly to the large sizes, the airports had to evolve at the same rate. The whole idea that we take for granted now of jetways or bridges coming down from the gate, and then you don't have to walk outside and climb up steps and that sort of thing, that was all new in the late 60s or early 70s. The airports, of course, if they were planning to use 747s, couldn't have as many bridges coming out from a building because of the wingtip clearance. And they had to work in concert with that. They had to make predictions, how many 747s versus the older DC-8s and 707s, and come up with a mix. And that's still going on. If you go to any major airport right now, you probably won't see three 380s parked Airbus 380s parked side by side, unless it's a new terminal. But the terminal building, from the inside, with you got 350 people milling around. You need a boarding lounge that'll handle that many. Parking, baggage, all that security, all that has to be adjusted to the larger loads. But then out on the airport itself, the ramps and the taxiways, they all had to be expanded. The runways, not so much. They really advanced the wing design on the 747. If you look at the 747 wing when it's clean and it's in cruise, it's basically the shape that you would imagine. But as the slats go out the front and all the triple slotted flaps go out the back, the thing turns into a huge curve, comes down to within just a couple of feet above the ground, generates an enormous amount of lift. So actually the 47s were able to use runways the same length as the ones required by the DC-8s and the 707s that came before. But the taxiways, they had to be farther apart so that you didn't get wingtips as you passed. So they all had to evolve together.
The 747 arose from Boeing's failed bid for what would become the Lockheed C-5 Galaxy. Another jumbo jet might have emerged from this same competition and come to challenge the 747. Boeing's fellow competitor, Douglas, was defeated with a similar-looking design where a cockpit pod sat on top a grand fuselage. They, like Boeing, tried to make the most out of their loss and morph it into a jumbo jet. In 1966, American Airlines was looking for a wide-body aircraft similar to the 747 in terms of range, but also able to land on shorter runways. Douglas, which had merged with McDonnell Aircraft, came up with a plan for a supersized aircraft. This early DC-10 design had tremendous seating capacity, up to 550 passengers on its 2 decks. However, the idea was rejected and was replaced with the much more conservative DC-8 Super 60. For decades, the 747 reigned as the largest commercial passenger aircraft in the air. In some ways, the crown was a heavy one for the aircraft to bear. It's true that its cost per seat could not be beat if the aircraft was filled to capacity. However, it burned almost as much fuel when 70% full, meaning airlines were burning money if they couldn't fill the seats. The recession and fuel crisis of the 1970s didn't help matters. Airlines were also changing the patterns of routes and relying on smaller aircraft to land at smaller airports in a point-to-point pattern instead of the traditional hub-and-spoke system where large aircraft go from major hub to hub. Still, there were several operators who needed the range and size of the 747. Boeing continued to refine and improve the design, increasing seating capacity, range, incorporating lighter weight materials, using more fuel-efficient engines, and stretching the upper deck. Like every king, the 747's reign was destined to end. In the late 80s, Airbus began laying the groundwork for a plane to break Boeing's domination of the jumbo jet market. A plane that would one day become the world's largest airliner, the Airbus A380. The radical plan was officially announced to the world at the 1990 Farnborough Air Show. Airbus's goal was to create an aircraft that was 15% more economical to operate than the 747-400. About the same time, McDonnell Douglas and Taiwan Aerospace Corporation tried to strike their own blow against the 747. The two companies and some smaller partners were looking to create a super jumbo which surpassed the 747 in seating. At first, they considered enlarging their trijet MD-11 and then the design ballooned into a 4-engine double-decker plane. McDonnell Douglas had, of course, already played with a double-decker DC-10 in the 1960s. Despite some early interest and a major marketing push, their new MD-12 design did not attract any customers. Taiwan Aerospace pulled out, and the project folded. Given the threats from Airbus and McDonnell Douglas, it's not surprising Boeing considered supersizing the 747. Boeing worked with rival Airbus to study the possibility of creating a VLCT, a very large commercial transport, and sharing its market segment. The $15 billion price tag to develop such a plane did not seem a worthwhile gamble to Boeing, and they abandoned the project. They focused on stretching and improving the 747 and building smaller aircraft. Airbus went ahead with laser-sharp focus on completing their giant killer, then known as the A3XX. The design went through several iterations. The company considered a side-by-side arrangement for two fuselages. However, they eventually settled on the now trademarked double-decker configuration. In December of 2000, Airbus put its money where its mouth is. They launched an €8.8 billion program to build the officially christened A380. There were 50 orders and 6 launch customers, which must have allayed some of the anxieties of the Airbus board. 5 years later, on April 27, 2005, the largest passenger plane made its first test flight, and in October of 2007, the A380 entered service with Singapore Airlines. The King, of course, did not go down without a fight. Boeing countered with the 747-8, a stretched version of their 747, and in fact the longest commercial aircraft in the world. Comparisons are often made between the two giants. The A380 has the clear edge in total seats, 525 versus 467 in a typical three-class layout. But the 747-8 is cheaper to buy, and according to Boeing, it is cheaper to operate. Perhaps the 747-8's greatest strength is that it cost billions less to design than the bolder A380.
When the 380 was built, Boeing said loud and clear, the world will not support it because the trend is towards point-to-point passenger carriage. And Boeing was certainly proved right. One carrier, Emirates Airways, has made a great job of the A380 because they're geographically located in a very favorable point on the Earth's surface as a connector between Asia and Europe.
Though Airbus has faced some early hurdles, over 330 A380s have been sold, and the company claims the project is well over the break-even mark. The A380 has, in its own way, become an iconic example of giantism. There is a new double bubble on the horizon, the D8. NASA took the double bubble fuselage design of the late 40s and turned it on its side. The D8 design has 2 fuselages in a side-by-side arrangement. The idea was developed by a research team at MIT, and Aurora Flight Sciences have received funding from NASA to build a half-scale model over the next 3 years. Placing the fuselages side by side helps to create more lift and makes for a more fuel-efficient aircraft. Compared with a similarly sized 737-800, it will burn 71% less fuel and release 87% less nitrogen oxide. The full-sized plane, which could be flying in 2027, will have 180 seats, a range of 3,500 miles, and a top speed of 582 miles per hour. Aircraft manufacturers and airlines looking for ways to ferry more passengers at once experimented with the double-decker design. Fusing 2 fuselages together may have seemed a simple and economical way to achieve this aim, but one still needed to find a way to power those resulting hefty planes. Too many engines burning too much fuel made for an aircraft too costly to operate. This was the fatal flaw of the Constitution in XC-99. By the time of Boeing 747, relatively fuel-efficient and powerful jets were available to power these supersized planes. It seemed to make more sense to build jumbo jets. However, travel patterns were shifting. By the 80s, moving masses of people in a flying arc along a hub-and-spoke pattern didn't make much economic sense. Still, the 747 filled a specific niche in the airliner market. In the 90s, Airbus sought to topple this king with a super jumbo jet. Their double-decker A380 is the largest passenger plane in existence and has clearly taken a bite out of Boeing's market. However, for airlines, like any other business, everything comes down to the bottom line. Perhaps the aircraft have become too big to be profitable to operate. These super jumbos might face extinction, just like the colossal dinosaurs before them.
This is the consolidated B-36 intercontinental bomber, sometimes referred to as the Peacemaker or the Big Stick. It was the largest conventional warplane ever built. It had tremendous range and a great payload. With its 6 piston engines turning, and later 4 more jets burning, the B-36 for many years projected America's military might.
It was a monstrous airplane. It had 6 engines, and they were pusher-props. Now later on they hung jet pods on the ends of the wing, but the early models were all piston engines, pushers. It was a huge airplane, and it was designed then to carry atomic weapons.
But by the mid-50s, its sheer size, cruciform shape, and middling performance worked against it in a world of pure jets. However, in its heyday, the 36 was the very pinnacle of successful giantism. Rather surprising given that a decade and a half earlier, the United States had all but abandoned the idea of operating massive aircraft known as XBLRs, or the Experimental Bomber Long Range. The first attempt, the XBLR-1, resulted in the Boeing XB-15. This was an ambitious and useful experiment that demonstrated the importance of 4-engined bombers. The XB-15 carried a crew of 10. However, its 150-foot wingspan proved too large for practical use. But Boeing's next offering, the XB-17, which followed a year later, perfectly met the needs of the Army. Despite the Army Air Force's decision not to proceed with the XB-15, the political mood in 1938 was undergoing a sea change. With the acquisition of total power by the Nazi Party, American military planners had to contemplate a scenario of German domination of Europe, including Britain. In America in 1938, the question being secretly asked was what if Britain did fall? Perhaps the only way of striking back at the Axis powers in Europe was with the once dismissed experimental bomber Long Range. The XB-LR-2 came together as the XB-19, somewhat bigger than the XB-15, and in fact bigger than any other aircraft in the world at that time. It was to be built by Douglas Aircraft in California. However, by the time the B-19 first flew, the Battle of Britain had already been won, when a few hundred pilots of RAF Fighter Command were just able to halt the Nazi juggernaut. Notwithstanding these events, the B-19 project continued. Some indication of the project's size can be gained from the scope of its planning. The XB-19 required no less than 4 acres of drawings, 500 engineers, and more than 2 million hours of R&D and construction. The wings on their own had a 212-foot span and were over 1/10 of an acre in actual size. The wings also held 4 giant engines. Each one had more than twice the power of those on the B-15 predecessor. The B-19 even had its own hoists for changing the 16-foot propellers, and was able to lift its own massive engines on and off the wings. Each wing contained a lighted passageway, enabling crew to reach the engines in flight. The two massive main tires were 8 foot high, and each was of 24 ply, using 150 miles of rayon cord and 3 miles of steel wire. All of the flying control surfaces were so large that they could only be operated via power-assisted devices. The rudder alone took up an area of 237 square feet of movable surface. To communicate within such a large aircraft, it was necessary to install a 24-set telephone system and a loudspeaker cum fire alarm warning device. And to enable missions of up to 3 days and accommodate at least 13 crew, it was necessary to have a galley, a wardroom, as well as a bunkroom. Such were the proportions of what Douglas liked to refer to as their hemispheric defender. In theory, this behemoth flying machine could fly more than 1/3 of the distance around the world without refueling, perhaps reaching parts of Europe and the return trip too. On June 27, 1941, the B-19 made its first flight from Douglas Aircraft in Santa Monica to March Air Force Base. Despite various suggestions to the local press at the time, the B-19 was really a proof-of-concept aircraft to explore what could be learnt about building giant aircraft. The B-19 also presented the same problems and lengthy delays as Boeing had endured with its 4-year development of the B-15. Knowing that many of the lessons recently learnt were already becoming obsolete, Douglas suggested that the B-19 be abandoned. However, the Army remained firm that the XBLR-2 would be delivered. In fact, the Douglas Company's view may have been quite sound, as the war had necessitated that the 2 prototype long-range bombers be ordered 6 months before the B-19 ever flew. The Northrop B-35 and its competitor, the enormous consolidated B-36, would use whatever data could be migrated from Douglas. In fact, the B-35's design was a totally different concept, relying upon advanced flying wing aerodynamics to gain maximum range, an idea that was far ahead of its time. Nevertheless, it was the consolidated XB-36 which the Air Force adopted. It was a symbol of pure 1940s giantism, and likely would have benefited from some of the ideas incorporated in the B-19. However, it was a virtual flying gas tank, carrying with it all the fuel it needed for a there-and-back European mission. The Second World War had come and gone before Consolidated's giant reached production, and as Britain did not fall to Germany, the 36's absence had no impact on the conflict, although its presence became critical in the Cold War that followed. It was during this potentially cataclysmic test that America's Peacemaker really came of age. The newly formed Strategic Air Command under General Curtis LeMay would regularly fly to far distant territories just to demonstrate its enormous reach. It was all a very effective show of force, although by the mid-50s, one that was starting to be questioned.
The airplane flew like a glider. It was easy to fly. Anybody could have flown it with 5 hours of stick time. It was a beautiful airplane. It's good that they never had to fly military missions, even with the 4 jet engines which were placed on later.
The success of an earlier Strategic Air Command gamble with the B-47 Stratojet medium bomber demonstrated the need for a faster swept-wing, all-jet-power heavy bomber. Yet Consolidated felt they could still provide a ready answer. The B-60 arrived after a standard 36 fuselage was married to swept wings and tail surfaces. It was propelled by 8 turbojet engines. The concept would have been economical, but advances in in-flight refueling made it no longer necessary for massive fuel loads to be carried. The age of giantism was coming to an end. Strategic Air Command wanted a smaller, faster and more sophisticated heavy bomber, and Boeing's B-52 Stratocruiser fitted the bill. And in terms of years of service for dollars spent, the B-52 was able to adapt and evolve in a way Convair's Big Stick never could. Still, credit where it's due. The B-36 was for a number of years America's sole intercontinental bomber and served as an effective deterrent, appropriately earning the type its other nickname, the Peacemaker.
It was during the early 1900s, when America was starting to emerge as a world power, that the first Roosevelt made his prophetic statement on international diplomacy. He advised to talk softly, but carry a big stick. Half a century later, when the United States stood as the world's champion against communism, its big stick was undoubtedly the Convair B-36 long-range bomber. Although this mammoth aircraft was to serve throughout the 1950s, it could actually trace its origin back even before America entered the Second World War. 36 was to earn its apt, if unofficial, title of Peacemaker. By 1941, the United States Army Air Force had 2 effective heavy bombers at its disposal. They were the legendary B-17, designed by the Boeing Company. This superb 4-engined aircraft was to serve throughout the war, and the heavily armed later versions were understandably known as the Flying Fortresses. A slightly later model was the consolidated B-24 Liberator. The Liberator featured an advanced tricycle undercarriage which permitted higher speed landings, and the design saw service in all theaters of the war. However, the larger, bulkier fuselage enabled some models to be converted into transports, making the B-24 one of the most versatile aircraft in the American inventory. The Liberator, like the 17, was also heavily defended, and it was also able to fly slightly higher than the Fortress. But more importantly, it offered greater range, so it was often used for maritime patrol work, flying what at the time were considered very long distances on internal fuel. However, the B-17 and the B-24 were only able to make the trip from America to Europe one way. In 1941, the Army Air Force also had on order another bomber, ultimately able to fly still higher and further than those preceding it. Another Boeing design, the B-29 Super Fortress, was undoubtedly the most powerful bomber to see service throughout the entire conflict. But even though several hundred were on order, there was not even a single prototype in the air. A second backup concept should the B-29 fail in any way was the consolidated B-32 Dominator. This aircraft was not produced in any great numbers, but it did provide a reassuring alternative to the superfortress's phenomenal capability. However, in 1941, it too could only be seen on the blueprint. By the middle of that year, continental Europe was in Nazi hands as the German juggernaut enjoyed success after success. More importantly, although Britain had regained some supremacy in the air, it still suffered from constant punishing bombardment from the Luftwaffe, which devastated its people and its industry. These raids, often at night, but sometimes in daylight, were seen by the German High Command as a means to bring the island nation to its knees. The burning question which American tacticians struggled with was simply, what would happen if the US was brought into the conflict and the sole remaining Allied base in Europe was to be lost to Germany? One possibility American strategists considered was the development of an aircraft with such phenomenal range that it would actually be able to start from bases on the American East Coast, fly the entire span of the Atlantic to deliver its payload, and then return to continental America without any form of refueling or fighter protection. The American aviation industry had produced long-range bombers in the past. The first of these was an early Boeing project, the XB-15. This aircraft was to have a wingspan of almost 150 feet, but needed all of the power of its four 1,000 horsepower engines to lift its 35 tons of bulk into the air. The second experimental long-range bomber was developed by the Douglas Company. The prototype, XB-19, was ordered in September 1936. This aircraft, with a wingspan of 212 feet, was still larger than the XB-15 when completed. The task required 500 men, 9,000 drawings, and 2 million man-hours, plus $1.4 million of the military's funds. It also cost Douglas an estimated $4 million over its original budget. Clearly, developing mammoth aircraft was an expensive business. Nevertheless, the XB-19 was a true watershed in aviation standards, not only in size, but also in innovation. It was the first aircraft built with retractable tricycle undercarriage and designed to have power-operated guns and a tail gun turret. Had it gone into production, it would also have offered a range of in excess of 7,000 miles. The information gained from the XB-15 and 19 projects, knowledge of the inadequacies of the aircraft inventory in the early 1940s, and the looming prospect of having to wage a European war from American shores, the American Defense Department contemplated the problems of producing an extra long-range heavy bomber to do the round trip across the Atlantic. To do this, it called upon designs from Northrop and Consolidated. The Northrop design was nothing if not unique. The concept worked on the premise that if an aircraft could be produced without the drag effect of the fuselage and tailplane, considerable range will be achieved. Therefore, Northrop set about designing an aircraft which by any other name was just a wing, a flying wing. And on the 25th of October 1941, an order was placed for 2 XB-35 experimental bombers. The Consolidated design was more conventional than its competitor in shape, but certainly not in size. With an overall wing area of just under 5,000 square feet, the B-36 was to require no less than 6 engines placed at the back of the wing to push its massive 163-foot fuselage through the air. And on the 25th of November 1941, an order was approved for 2 aircraft in the hope that the first would be developed by mid-1944 at a fixed fee of approximately $800,000 each. As it happened, the much-needed bomber bases in Britain were never denied to the Army Air Force. and as a result, the standard B-17 and B-24 heavy bombers were able to attack Axis targets from 1942 onwards. Delivered in their thousands, the fortresses and liberators were to wrench a terrible price from the enemy. The longer distances required by Pacific theatre were amply met by Boeing's B-29, especially after the capture of the Mariana Islands in mid-1944, which gave the superfortress the stepping stone which enabled the Air Force to reach the heart of Japan. But it was one particular B-29 with one particular bomb that was to bring the Second World War and much military aircraft development to an end. Two exceptions to this were experimental long-range bombers ordered only weeks before American involvement in the conflict, but never given sufficient priority until the war's end, and need to deliver a new weapon, never perceived in the tactician's wildest dreams 4 years earlier. The first Northrop B-35 was actually constructed in the open and completed in June 1946. This clever design, which was the source of controversy for many years, was powered by 4 pusher engines and was intended to carry a crew of 9 in the pressurized center section, for its shape barely allowed the word fuselage to be applied. However, the radical new shape, which relied upon flaperons on the end of each wing in lieu of a conventional tailplane, was never to completely overcome stability shortcomings. But the flying wing must surely go down in history as one of the most brilliant aviation concepts ever conceived. The first XB-36 was wheeled out of the experimental hangar just 6 days after Japan surrendered, but it was to be August 1946, nearly 5 years after it was ordered, before the Peacemaker was to be ready to fly. The prototype's single main wheels were 100 inches in diameter and the largest ever made for an aircraft, but this was to prove a major weakness. The 6 pusher-type engines were to have their air intakes on the forward section of the wings. However, this advanced concept for the time was also to provide initial difficulties in cooling the engines and would require later modification. On August the 8th, 1946, the first XB-36 under the command of Captain Beryl A. Erickson rolled down the Fort Worth runway with a total crew of 9 and 8,000 gallons of fuel. At exactly 10 minutes past 1 in the morning, he lifted Convair's giant aerial masterpiece into the air for the first time. It was the biggest plane ever to fly, even in Texas. The flight was to continue for no more than 37 minutes, during which time the undercarriage was to remain in the wheels-down position as a safety precaution. Erickson's crew on this and many subsequent occasions were to put the giant aircraft through many vigorous tasks which quickly identified the problems of giantism, one of the most formidable being the vibration caused by such enormous engines spaced out over the wide distances of the wing, and cooling was another problem, especially at high altitude. It was obvious that there would be many areas requiring major attention. But perhaps the most fundamental was the simple concept of the massive wheel arrangement which limited Convair's bomber to runways at least 22 inches thick, and as there were only 3 of these available anywhere in America, clearly an answer needed to be found, and found quickly. The answer came in what was considered another breakthrough, by combining 4 56-inch wheels into a group under each wing, thus spreading the B-36's phenomenal weight over the much wider area, thereby permitting the Peacemaker to use runways of half the previously required thickness. Very early in the B-36 concept, Convair could see the potential of utilizing its enormous wings and tailplane for the transport version of the Peacemaker's commercial cousin, the XC-99, which was ready for its maiden flight in November 1947. Still larger again than its bomber counterpart, the 99 was assembled at Convair's San Diego operation, but with wings and other common parts shipped across the nation from Fort Worth. Here at Lindenberg Field, what had now become the world's largest plane was to demonstrate the potential that would lead to the mammoth transport and airline concepts that followed decades later. The 99 was to attract considerable attention by Pan Am, who seriously considered a civil version for the west coast of Hawaii run, and actually took out options on 3 such aircraft, but as predicted, the early post-war airline boom was not to transpire for many years. The XC-99 was never to see civil service, and the sole example produced remained in active service with the Air Force until 1957, and became particularly invaluable during the Korean War, when it was used to rush essential payloads from one side of the nation to the other. This aircraft too had to be modified with a new undercarriage system, but when it was, it proved extremely versatile and had, if required, the potential to lift 400 fully equipped troops. Yet, practically, it was just too soon for its time. However, Convair's main interest had always been with the extra long-range bomber concept, and it continued to develop and refine the B-36 throughout the late 40s, emphasizing that this weapon alone provided the ultra-long range to strike virtually any target in the world and return to its base in America. Long range would require many hours of physical endurance for the crew, and therefore inside the 36's massive fuselage, adequate provision was made for sleeping quarters and a galley complete with a 2-burner stove. Ample provisions were always provided. However, the center pressurized section which held these amenities was actually no less than 80 feet from the forward control area, which was only accessible via a narrow tunnel spanning the distance. Heated food was packed in specially designed containers for conveying between the vast distances of the 2 pressurized sections. The tunnel also served as the only means to convey personnel from one crew section to another, and because of the distances involved, a small trolley was provided to enable each member to propel himself more effectively. Problems generated by the size of the 36 also required other unique procedures never previously required by other aircraft. Immediately after takeoff and before the plane was pressurized, a crew member was given the responsibility of examining certain vulnerable areas within the massive interior structure which formed the fuselage of the 36. Only then would the plane be allowed to climb to higher altitudes and continue with its mission. Other problems in dealing with the size of the 36 came to light. There was the question of how to service each of the massive aircraft which was so big that special outdoor hangars had to be constructed so that only the essential parts could be accessible. And although the problems of engine vibration and cooling had been successfully resolved, there is no doubt that there were grave concerns with the viability of the B-36 in competition with other alternatives. Firstly, the project's original competitor, the Flying Wing, had been upgraded to an all-jet aircraft, replacing the 4 propellers with 8 turbojet engines. Northrop hoped to increase the speed and viability of its quite brilliant concept, which utilized unique flaperons, shown here at the end of the wing, to make up for the absence of the conventional tailplane. Another more conventional competitor of the 36 also came from the past. This was the Boeing B-50. The aircraft was really just a standard superfortress of Second World War vintage, but with more powerful engines and extended range from the underwing mounted fuel tanks. This range was enhanced yet again by Boeing's successful development of aerial in-flight refueling. Thus the Air Force had available to it a proven airplane combination which could fly the same range as the 36, but without having to address the problems of giantism. By the late 40s, due to these innovations, the future of the B-36 looked very bleak indeed. Its salvation came from two major developments. The first one, poetically enough, was also provided by Consolidated's long-term competitor Boeing. For Boeing developed the successful medium-range bomber entirely powered by jets, but utilizing captured German technology which showed the benefits of a swept back wing. Boeing's B-47 was to have the wing that was not only swept, but was so flexible that it could move within an arc of 17 feet. However, so that the wing would remain thin, the 6 engines had to be mounted in pods suspended from below. The outer pods contained 1 engine apiece, but the inboard pods contained 2 engines which were suspended several feet below the wing surface, and it was with this equipment that the engineers from both companies worked together to attach to the far outside wing of Boeing's Giant. With 6 turning and 4 burning, the 36 was at last, in part, entering into the jet age. The other event which was to secure the future of the 36 took place on June 24, 1948, when the Soviets closed the gate on Berlin, signaling in one step the beginning of the Cold War. Now, the growing concerns of communism polarized into an action which shocked the West out of its post-war complacency. As NATO forces now found they were confronted with a potent adversary, in a matter of days the need for an intercontinental bomber had gone from hypothetical to the very real. At this stage, there was no one plane in the world able to fulfill the long-range potential of the Convair Giant, and rather than cancellation, orders for the Peacemaker were actually increased. As concern continued, the importance of America's Strategic Air Command, which was responsible for long-range bombing, increased considerably, and it was ultimately placed under the direct command of General Curtis LeMay. LeMay had an impeccable Second World War record. It started with his early involvement in the European bombardment with the Army Air Force, continued to when he took command of the Pacific operations and the B-29 bombardment of Japan. Considered one of the great strategists in American wartime experience, he also supervised the Berlin airlift and was now seen as the most qualified person to bring the Strategic Air Command, including its fast-growing fleet of 36s, to the highest possible state of readiness. Under LeMay's iron leadership of SAC, the American public took comfort in the fact that, although they now no longer had a monopoly on atomic weaponry, that at least they had what was probably the best platform for delivery, the B-36. So concerned was the military about protecting its intercontinental bomber that security was stepped up to effectively a wartime footing, and personnel in SAC control rooms were required to carry firearms, even though they were in fact hundreds of miles inside American borders. The concern to protect America's big stick even required mechanics servicing the engines to carry firearms whilst they worked.
Engineer checklist complete. Ready for takeoff. Over. Audit checklist complete. Ready for takeoff. Roger, give me 100% of it, Jack. Roger. That's coming up. Engineer, give me full power. Full power coming over. Jets 100%. Safe flight jet okay. Takeoff power is set. Everything stabilized. Engineer ready to take off. Roger. Cardinal Tower, Air Force 653, ready to take off. Air Force 653, Cardinal Tower, Roger, 30 roll. Roger, 653, rolling. Here we go. Engineer, give me climb power. Roger. Climb power coming on. Be 96% on the jet. Roger, 96% on the jet.
Usually flying as single aircraft rather than in formation, SACs peacemakers would practice bombing raids over vast distances and at next to no notice. The 36s utilized a K-1 bombing navigation system for precision accuracy. The K-1 system contained no less than 365 vacuum tubes and enabled the 36 to bomb at high speed in any weather.
Pilot, go ahead. Pilot will be over the 5 point and 20 minutes.
The target was usually a radio signal from special trucks built to gauge the accuracy of SAC's aircraft. Although the fact that B-36s were to cost over $5 million apiece, they, together with the K-1 system and LeMay's insistence upon constant training, provided a combination which was anything if not accurate.
Over 5 feet. Pick up the heading of 197. Top water for 653. Over the I-6. Up 35,000. On an 8-mile heading of 197 degrees. Top water for 653. 30 seconds to go. The clouds away. 5 seconds to go, Bob. No switch coming on.
The pencil in the plotter's hand represents the plane moving over the graph scale towards the target.
On the way.
However, despite the enormous potential of the Convair giant, detractors often considered its large size to make it a prime target for enemy fighters, and even before the first 36 even flew, the Air Force ordered a unique auxiliary, the McDonnell Goblin, as a Parasite fighter to be actually carried within the B-36. This incredible design consisted of the barest essentials and had fold-dart wings which would enable the aircraft to be totally concealed within the 36's bomb bay. Never actually used with the Peacemaker, its flight controls were conducted from a B-29 mothership, and flight trials commenced in 1948. In August, with test pilot Ed Scorch secured in the cockpit, the Goblin was launched by a trapeze mechanism from the B-29, and the pilot successfully flew what must be one of America's most remarkable fighters. However, when Scorch came to reconnect the Goblin hooked to the trapeze, turbulence lifted the little fighter, and the mother plane mechanism broke the canopy and wrenched the oxygen mask away from the pilot. But Scorch was just able to regain control and crash land this tiny fighter. But this setback did not stop development. Second and only other Goblin produced continued its task. Eventually, on October the 14th, 1948, a successful hookup was effected, and the Goblin pulled into the 29's belly. But this bomber-parasite fighter combination, although bold in concept, was never to be adopted because it seemed to present as many problems as it tried to solve. However, a later Parasite project involving the B-36 was the Phycon fighter conveyor concept. This program began in 1952 and involved mating up a Republic F-84 directly underneath a modified Peacemaker. There was no intention of fully concealing the F-84 within the mother craft. Not until after the aircraft and its Parasite were in the air would the fighter pilot enter into its cockpit, and he, working as a team with the highly trained boom operator who was positioned in the mother plane, would attempt the delicate and skillful task of lowering the fighter via a large hydraulic-operated boom to a point below the bomber where the fighter could be successfully released. This task actually proved very successful, and the process of recoupling, although requiring great skill, was perfected to a fine art. The combination of these aircraft provided many potentials, especially as the pilot was able to come and go from the fighter when it was in the docked position. In actual fact, the Falcon mission was really conceived more to extend the reconnaissance capacity of the B-36. The F-84, either in its straight or swept wing form, was an extremely versatile aircraft, and although SAC employed it as its own fighter aircraft, there is no doubt that it could perform the role of an effective fighter bomber, as it demonstrated so capably over Korea. That SAC could now carry such versatile aircraft thousands of miles to the very edge of enemy territory, and small compact nuclear weapons were under development at the same time, it seems probable that SAC could have used its Falcon combination in the bomber role. By the middle 50s, the B-36 was fully developed and deployed at various SAC bases around the nation. By the early 50s, SAC's Peacemakers were at the peak of their development, with the early engine and vibration problems resolved. With the support of jet power and modifications such as a new quick-action bomb bay door, the B-36 personified the ultimate intercontinental atomic bomber of the era. But despite the technical success of the project, it still was to continually suffer from political and inter-service criticism. And even as early as 1949, there had been an investigation into the political influences relating to the 36, all of which came to nothing. But the Navy's resentment of the Peacemaker was stronger and probably more founded. Its promised 65,000-ton supercarrier was to have the capacity to deliver atomic attacks on would-be Soviet industrial centers, and was cancelled, partly because of the Air Force insistence that the 36 deterrent was far more flexible and did not represent the eggs-in-one-basket philosophy of a carrier. What was equally important was that SAC claimed it was just as able to operate from the edge of enemy territory and in conditions that would have been impossible for naval aviation. To demonstrate their point, B-36s would regularly fly from their home bases in central USA to the very edge of Soviet territory. Highly trained crews of pilots, navigators, radio operators, engineers, and gunners would prepare for long hours of flight, often at very high altitudes, over thousands of miles to the frozen wastelands of Alaska. These men would know that once into the Arctic region, should their aircraft fail and crash land, and some did, there was very little chance of survival in the sub-zero and uninhabited wilderness. Against these prospects, the roar of the Peacemaker's 6-piston and 4-jet engines must have sounded far more a blessing than a curse. The Navy's criticism of the Peacemaker still continued. One time they actually made a formal request to the Air Force for the use of a 36 to test its defensive capability against Navy fighters. Outwardly it displayed very little defensive armament, but covered under sliding panels, the Peacemaker concealed 6 remotely controlled turrets, each with 2 20mm cannons. These turrets could be hydraulically raised as required, and when used in conjunction with the forward nose turret and radar-controlled rear turret, combined to offer no less than 16 cannons, covering every approach for a range of over half a mile, making the Peacemaker the most heavily defended aircraft in aviation history. Ellison Air Force Base in Alaska was a point to which many B-36s on exercise would travel. Here, Peacemaker's captains would land their massive aircraft, never knowing beforehand just what weather conditions would prevail as they made their approach. For some, the function would be little different than that at Offutt, thousands of miles away. But with the weather constantly changing, for others following close behind, visibility would be close to zero, testing the pilot's skill and resolve to the limit. Once down, each aircraft would be quickly guided away to its service area, and waiting heated buses would be quickly on hand to collect the tired and weary crew, who, despite the winter protection, would doubtless be noticing the contrast from what might have been Texas to Alaska non-stop. So cold was the region that if aircraft had been standing for anything more than a short time, the engine would require supplementary heating, mainly through the giant air intakes, to ensure the equipment was not frozen solid. To achieve this, large mobile heating plants were developed which could pipe vast amounts of hot air into and around all the piston engines. The crew compartment was also given the same treatment, not merely to make the area habitable, but because the instrumentation and on-board equipment simply would not work effectively in such a cold environment. Refueled and ready to go, 36s would again brave the cold Arctic sky on the way back south, leaving the area to its natural inhabitants. But the real purpose of these exercises was to demonstrate that from Alaskan bases it would be just as easy to turn northwest to Soviet territory and deliver the devastating cargo around which the 36 was developed. Cargo of another sort was identified. Convair, which designed the 36, won the contract for the Air Force's first supersonic bomber, the B-58 Hustler, which was the culmination of Convair's long involvement with the Delta design. It was found that moving from base to base, an as yet unflown bomber, was not an easy task, until it was temporarily mounted under a standard 36 with its two inboard props removed to protect the Hustler wingtips. Perhaps this image symbolizes beyond all else the difference between the two generations of aircraft. In the space of less than 10 years, West, the speed of bomber aircraft had so radically changed the shape and size that tomorrow's medium bomber was able to fit comfortably under yesterday's heavy bomber. Clearly, the age of giantism was coming to a close, and yet Convair still held hopes for its mammoth in an upgraded form. The company produced the YB-60 in response to the Air Force requirement for an all-jet heavy bomber. Hopes were high at Fort Worth in April 1952 when the 60 made its first public debut. The continuation of the production line would guarantee the jobs of thousands of staff involved and subcontractors. It would have brought added prosperity to the city, which had produced the world's biggest bomber. The YB-60 was virtually a B-36 with new fully swept wings and tailplane. Having no defensive armament other than the rear turret, the entire rear crew and quarters were omitted. Added power and less weight brought the YB-60 to a top speed of just over 500 miles per hour, and its production was achieved in rapid time, as 70% of its components were standard to the 36. Two such examples were ordered by the Air Force to test the concept, but only one was to actually fly. The apparent enthusiasm of the test crew was not shared by the Air Force. They preferred Boeing's all-new design B-52, the Stratocruiser, which, although more expensive, offered better performance in range and speed, shown here next to the original Boeing heavy bomber. On August 14, 1954, a ceremony at Convair's production line in Fort Worth, the last B-36 was handed over to the Air Force. Final delivery from the Peacemaker plant must have been a bittersweet affair for the Fort Worth people, because although Convair was to continue to use the plant for many successful projects, it was this base that they had produced what was for many years the biggest plane ever to fly, and a plane, many would say, because of its sheer size, won a war without having to fight.
The Boeing 747-8 and Airbus A380 are titans of the sky, clashing with each other for dominance of the airways. These twin-level aircraft move packs of people across the world at a pace which was once unimaginable. They offer airlines a mix of technical sophistication, luxury, and the promise that they will become the golden geese of their fleets, something for which airlines are willing to pay hundreds of millions of dollars. The lineage of these advanced aircraft can be traced back to the pioneer days of commercial aviation, when moving a handful of passengers was an achievement. Many giants would come before the 747 and A380, and many would fall. As bold as these aircraft may seem, new breeds are on the rise to surprise and surpass them all. The Boeing 747 jumbo airliner, an icon among all other commercial aircraft of the time, and an absolute cash cow for those who invested in it. Equal to the jumbo's size was its massive cost, far more than its designers could afford. Boeing had to look for partners, and big ones. But despite its success with the earlier 707 jet airliner, the money needed would be hard to find. Boeing thought that a likely candidate might be General Motors, one of the largest companies in the world at that time. They were to be disappointed. The car maker did not want to put its profits into an entirely different industry, and so it was that Boeing looked closer to home. In the end, two other aeroplane makers, Northrop and LTV, formed a triad to share the costs with Boeing and, ultimately, to enjoy the very considerable profits. The 747 actually had its origins in a design competition for an even larger type of military transport, the C-5 of the U.S. Air Force. Eventually, Lockheed won that contract, although not before Boeing had concluded that aircraft of such large size would be more useful when the flight deck was raised above the main floor, which permitted greater area for payloads of every kind. Boeing retained the two-level idea, and it was used in its next project, the 747.
Boeing used a lot of the design for the C-5 and put it into what became the 747, particularly in the wing and the engine technologies that were used. Probably without the C-5, the 747 would not have happened. Certainly it wouldn't have happened as quickly as it did.
Both the 747 and CX-5 would require a new breed of engine to get their supersized airframes off the ground.
To make a big jet work, you've got to have a big engine. And the 747, of course, required 4 of them.